understanding elements. An element with a different number of neutrons but the same number of protons is called an isotope, which is this. You can create elements by removing and adding the number of protons and neutrons in an already existing element. You must have a particle accelerator here, or a nuclear reactor, which is a reaction here.
Particle accelerator. This is what scientists need when they're making a new element. It costs about $6.7 billion, so this is just a diagram of one. We can't actually use a real one. So what we would do is we would put two elements in. This is hydrogen. This is unbibium. And when you put unbibium in here, it would rip apart the atoms going very fast, combining with hydrogen in the particle combustor. And when it came out, you would get a new element, JE, unalexithymnium. And that's how the particle accelerator works. To further understand what happens in the particle accelerator, I'm going to use element 110 as an example. After element 19 was discovered, there were no more gaps left in the periodic table, so they had to create their own elements. Now, what happens in the particle accelerator is PB would have its atoms ripped apart, and it would then combine with nickel. But then you have element 19 again, with 109 atoms and electrons. So what they would do is they would add one more neutron to get their new element. This is calculating the atomic mass. Our element is JE. The atomic number is 123. Now, to find the atomic mass, we would need to multiply the molar mass times the percent, or the subtotal mass. But because our element is so unstable, it's impossible to calculate the molar mass or the subtotal mass, making our element atomic mass unknown and impossible to calculate.
Glossary. Molar mass is the mass of a substance divided by the amount of the substance. Subtotal mass is the molecular composition, shows the amount of each element contributes in a molecule. Atomic mass is the average mass of atoms in an element. Molar mass multiplied by subtotal mass. Particle accelerator is equipment used to create an element. Costs $6.7 billion. Nuclear reactants, aka nuclear reaction, is required to make an element. Subshells. Subshells are shells within an electron energy level shell. Thank you for watching.
A view of what our element would look like on the periodic table. It would have our atomic number over here, 123. You would see it's radioactive from the symbol in the top right corner. Our chemical symbol is JE for the middle initials of me and Thomas. And our element name is underneath our chemical symbol, unalexithymnium. There's a question mark right here where the atomic mass would be, but since the element is radioactive, we cannot calculate the atomic mass. Now this is the periodic table right now, but it would continue on to element 122, which is unbibium, and then our element, unalexithymnium, would go right there, right next to unbibium. So that would just continue on. It wouldn't go into the noble gases. We would just add it on to the periodic table.
If you break the name of the unknown elements down, such as unbibium, you get un-bi, bi, And since bi means two and un means one in Latin, it reads 122, and its atomic number is 122. So naturally, unalexithymnium would be unbitrium, but the name isn't as important. This is just what our actual name would have been if we didn't have creative minds.
Some more basic information on the elements before our element. I'm going to discuss unbibium with you. Now, unbibium is the element 122. right before our element. The chemical symbol is UBB. To make this element, they combined uranium and zinc in the particle accelerator. It is radioactive and very similar to our element. The name and chemical symbol is temporary because the element is mostly unknown. Thank you for watching.